In the harsh conditions of northern Germany, it is very important to have a reliable companion by your side. Like the TS100 miniature soldering iron. Because you never know when the next soldering opportunity comes along. Today we are out in the field to harvest some fresh components. It is the season for electrolytic capacitors, so let's wait for that horse and see what Dexter can track down.
Hello.
He needs a bit of encouragement, but usually he's reliable too. Bingo! A wild growth of large capacitors. Yeah, I think I'll take those. The TS100 can heat its tip from 20 to 300 degrees C in only 12 seconds, which is already amazing. But it can be even better than that, because right now I'm only using an 18-volt Makita battery pack. To get the full 65 watts, you have to supply 24 volts instead. So I think it's time to take the quarry home, and then we can make a good 24-volt battery pack from 18650 cells. But first, let's check out the soldering iron and its performance in ideal indoor conditions. No thanks. This beefy 24-volt supply should be able to deliver enough power, I expect. So they didn't lie about the 65 watt at 24 volts. And the resulting heat up time is incredibly short. Almost as good as my 250 watt JBC, but that one has a much higher thermal capacity, so that wouldn't be a fair comparison. Also not a fair comparison would be one with an 80 watt Weller that is sold at 5 times the price of the TS100. But let's give that one a try, just for the fun of it. Both are starting with equally sized cone tips and at room temperature. Well, Weller, how disappointing. Okay, but warm-up time isn't everything. Let's do a real-world benchmark and see which soldering tool is faster when it comes to heating up one of these large pads. I've applied a small dab of solder to both tips to get things started, so that we hopefully get to see something in the next hour. Weird. TS100 wins yet again, even though according to the datasheets it's the less powerful unit. Maybe it's because my right hand is unconsciously applying more force. Or that large tinned trace is stealing heat away from the Weller. Or the capacitor terminals are asymmetrical internally. Maybe all of that. But I've also done the test in reverse, and the result was even clearer in favor of the TS100. I can't prove anything, but I'm convinced that what makes the difference is the integration of the tip with the heater and the temperature sensor. In these cartridge systems there is no additional material transition and no unnecessarily high thermal resistance. I really can't prove anything, but I can sacrifice one of these cartridges to science. Because I have 3 and I only ever use this conical bevel one for everything. I have a couple of ideas with varying degrees of destruction. The first one being to reshape a tip. If it still takes solder after that, we can move on and try something else. One thing I can tell right away is that this will have a disadvantage at some point, because I've exposed the copper inner core, and knowing my Chinese products, I'm sure they wouldn't go with a multi-layer construction if they could get away with less. But it still solders just fine. The problems might come with lead-free solder, special fluxes, or very fast oxidization. But for now we can try another thing. I want to turn it into a reservoir tip for easier drag soldering, because ever since Dave has shown one on the EEV block, I wanted one. Now I've got a small hole in my tip that can be filled with solder. Sounds unpleasant, but works incredibly well for SMD soldering. As you can see here, I'm applying a bit of flux to the part. And just by dragging the reservoir tip over the pins, the perfect amount of solder is dispensed automatically. This has worked surprisingly well, so I think we can apply those modifications to another candidate. Maybe later. In the next stage of controlled destruction, I wanted to drill a hole all the way through the tip and another one somewhere in the shaft to create a makeshift desoldering tip. But at this point my plans finally failed because I broke a high quality drill bit in there. It must have encountered a ceramic filling, and I should have expected that in a high temperature heating element. So now I suggest we move on to the final stage where we cut it open and look at the construction. Only 2 wires in here, so they must have a heater and a thermocouple in series. The tip contains all that matters, and it is just pressed inside a stainless steel tube. And here are a few fragments of the infamous ceramic filling. To me this construction seems good and durable, and I'm positively surprised that the tip still works after all this abuse. I think I should provide a true Viking funeral for it. No, this time it's not a post-production effect. Wow, it even survives its own Viking funeral. Inside the soldering iron there are no surprises, because the schematics are available publicly. Nice springy copper contacts for the cartridge, and a high quality, long-lasting DC jack too. As a main power switch they are using back-to-back MOSFETs. Good choice, I approve. As a thermocouple amplifier they are also using a single good quality op-amp. As an input voltage pre-regulator they are using an RT7272B, which can take up to 36 volts. So I think it wouldn't be devastating to supply 1 or 2 volts more than the nominal maximum of 24 volts. We'll have to keep that in mind for the battery pack build that will commence in a moment. Apart from that, there is only a TMP36 for cold junction compensation, and a 3-axis accelerometer for your soldering iron gimbal stabilizer. Couldn't survive without that feature anymore. Now let's get to the 24 volt battery pack. I've salvaged a lot of good quality 18650 cells from an e-bike battery. As you can see, there are no terminals per cell, which means that the manufacturer has not equipped a battery management system. Without one, good quality close tolerance cells might just barely outlast the warranty time, but relying on that is so unprofessional. So for this side dish, I'm using a cheap 6S BMS from eBay and call it a day. But the topic and possible DIY approaches are quite interesting and will be picked up in another video soon. For now I'm using my homemade spot welder and pure nickel sheet metal to connect 6 pairs of 2 in series. A bit of physical strength is provided by these battery holders that can be found by searching for radiating shells. I would have loved to heat shrink the entire assembly, but even the largest diameter I had didn't quite fit. So I guess I have to find some sort of enclosure for that. But that's it for now. Very impressed with the soldering iron. It was given to me by Banggood in exchange for a purchase link in the video description. No more and no less has been agreed upon, so this review is 100% unbiased. Although they might send me more toys if a couple of purchases were made via that link. Either way, thank you for watching. I hope I could demonstrate a couple of new things, even though the TS100 has been shown many times before on YouTube.